Hello everyone, I'm the Great Gatsby. Now, a little while ago, you may have watched my little video about making a Fnaf fan game in just 24 hours. And as I was looking around on YouTube, I realized that there's not actually a good tutorial for a Fnaf fan game. Like the earliest one is like from way back in GMS 1.8 or something like that. So I decided to make a new, more updated tutorial so that you can make something similar to the game that I made. And what you see before you today is what we're going to be making today. Obviously, the enemies aren't in the game yet, but you'll be able to open it up and poke around a bunch of different rooms, move the camera around, and so forth. But without further ado, let's go ahead and get started and jump right into Gamemaker. Now the mic quality for this video is going to be a bit lower. That's because I had to sit in front of my computer while I recorded this. My other microphone that I generally use for making videos is generally much better, but it's nowhere near my computer, so had to trade that off, of course. So audio is probably going to be pretty bad, but I hope that there'll be enough here for you to pay attention and to learn something. Alright, so I'm going to assume that everybody watching is an absolute novice with Gamemaker Studio, so I'm just going to show you how to set up a new project. You do this by, of course, clicking the New button. Now, here when it says Select Project Type, we are obviously going to be making a game. We can select from various templates here, but none of these are really going to be useful for us. So we're going to do a blank game. Now there's two options here, a blank pixel game, which is more for pixel art, and a blank game, which is for non-pixel art games. What this generally means is that the pixels are interpolated, which makes the image a little bit smoother. And FNAF is definitely not a pixel game, so we're going to go for a blank game. And then this is where you save where the thing needs to go. Now, you might see something that's like, do you want to make this project in drag and drop or in GML? We're going to be using GML for this tutorial, which stands for Gamemaker language. We're going to do actual programming. And there's a very specific reason for that. The reason for that is really quite simple. You see, generally in other game engines, drag and drop works fine. In Gamemaker Studio, however, the drag and drop is notoriously awful. It's very, very difficult to use. There's not a lot of documentation or help online for using Gamemaker drag and drop. And generally, it'll just break your game. You'll never really finish if you make a drag and drop game. Gamemaker language, on the other hand, is actually more simple than it appears. It's definitely easier to use than drag and drop. And on top of that, if you learn how to actually program, not only can you make a lot more projects with more creativity, but you'll also have a skill that you can transfer to other things outside of game design. So that's what we're going to be doing. As we go through this tutorial and we dive into how to code, I understand that many of those watching might not have any coding experience, and that's okay. I'm trying to make this tutorial available for everybody of any kind of skill level. So before we get into coding, let's just get some understandings and that kind of thing out of the way. Programming in Gamemaker Studio is actually really, really simple, but there's some things that we need to watch out for. So when you write something in Gamemaker Studio, let's say we want to make a variable that's called variable. If we set up a variable like this, a variable is just essentially a name for a number. We can access it like this. So x is equal to variable. So this line of code would basically just set up this line of code would set the x of this object to 0, right? Well, remember that capitalization is very, very important. So this capitalized V variable is completely different than this variable. In fact, if we run this code, we'll actually get a crash. So as you can see, it says error in action event number 1, step event 0 for object obj underscore game, variable unknown object dot variable, not set before reading it. So what this is saying, like, okay, right here in your step event for obj underscore game, so we go to obj underscore game, we go to the step event, at line 4. So step event line 4. This variable, capital V variable, was not set. So we're trying to tell Gamemaker, okay, set x equal to variable. But Gamemaker has no idea what variable is because we used a capitalized letter. So we are not able to do that. Make sure that when you spell things, the names are exactly the same. So as you can see, that runs just fine now. If we're going to be using a sprite or something, so SBR underscore cubicle 1, make sure to spell it the exact same way that's spelled here. So see how it's spelled here, SBR underscore cubicle 1. If you want to change this name to something else, that's fine. Like if you want to change it to, I don't know, Bazinga. This is automatically changed for us, but it needs to be the exact same name, right? It can't be like SBR underscore Bazinga because that's not what it's called here. It needs to be the exact same name. So let's go ahead and rename this to SBR underscore cubicle underscore 1. Perfect. Finally, there are different colors generally mean different things. So variables are generally blue. So check this out here. So as we can see, this is a green variable. So a green variable is a built-in variable. Basically, Gamemaker set it up, it's Gamemaker's, and it means something, and it works with something inside Gamemaker. This is why, if you want to set up like health or something, don't use the health variable, because that's tied. That's a built-in variable, and what that means is that it controls something in Gamemaker. And if you start setting it up with stuff, it might behave in a strange way. So if we ever want to change the x position of an object, if we want to change this object's x position, we use the x built-in variable. Same for the y, etc. A blue variable is called a local variable. So local variables, we always have to set them up. We always have to set them up somewhere. And basically, these are variables that can be just about anything. Like you can set it equal to a string. Hello world. You can set it equal to a sprite, SBR underscore cubicle, whatever. But these just hold different data types. Now this is a temporary variable. So this variable only exists in this step. Like I can't go to another event. I can't go to this draw event and call a variable. See, it doesn't work. It's the wrong color. It's not light yellow like this. This would give me an error because I haven't set up that variable here. This variable only exists in this space. Whereas I can use this variable here just fine because it's a local variable. So that one has a little more leeway. And finally, this orangish color is a function. So as you can see, various functions. So like one thing that you might see as we go through is, and this is very, very common, you might misspell something like this. So it's like array length instead of array length, as you can see. And if it's not the right color, if it's not the same color that it's supposed to be here in the video, then there's probably a spelling error. 99% of errors with programming are spelling errors. But we can get around them if we know what we want to spell, and if we look carefully at the error messages. So like if you run your program, you get an error message like this, it'll tell you, okay, it's in this object, it's in this event, and it's this line that says this. This is why it's wrong. And then finally, this is the line it's on. So we can go, okay, we know it's in the game object, we know it's in the step event, we know it's at line 3, and we know that Gamemaker thinks that this is a variable. We don't want it to be a variable, we want it to be a function. Just like that. That's perfect. So if you get stuck, if you get an error like that, rewatch the video, rewatch the section, and pay very, very close attention that my code and your code is the exact same. It needs to be exactly the same. Now, other bugs you might see with the game is, let's go ahead and create a little example here. You don't have to do this. Don't do this. I'm just doing this for example. You might run the game, and it might be that something is off center. So like as you can see, oh, this is clearly a visual error, right? Like it doesn't look the same. It doesn't look how it's supposed to be. Well, generally for that, there are a couple of problems. First, there's something wrong with the sprites. So like I just demonstrated, we are drawing this sprite from the top center, which is wrong. It needs to be drawn from the top left. If you have different sized sprites, different sized rooms, different sized cameras, etc., then you might have to change the sizes around so that it works. So like if you aren't using my sprites, for example, and you're using a smaller sprite, you'll probably are going to need to change around some of the stuff here, as like your camera size is going to have to be a different size, your room size is going to have to be a different size, and so on and so forth. Because your coordinates, like your variables and stuff like that, the ones that work for me are going to be different than the ones that work for you. So that's why I am going to provide the resources I used in this project, as well as the project files themselves for you to download so that you can follow along perfectly. And you don't have to worry about different sizes. If you want to make your own game with your own characters, your own rooms, all that stuff, totally fine. I want you to be able to build off this knowledge that you gain here. Just bear in mind that you might have to change around some of these variables, some of these numbers and stuff like that. And that will depend on what kind of sprites you're using. So just be aware. Perfect. So now we have our brand new project in Gamemaker Studio. And let's get right into making something. So the first thing we need to do is set up the project so that we can continue to build stuff off of it. So basically what we're going to do is we're going to start off by making 2 rooms, which I've already done here. So to make a room in Gamemaker, you can right click on the folder you want and then hover over create. And under create, you should see room right here. You can also press Alt R to make a room immediately. And when you make a room, you're going to have to name it. So the first room that I made is called RM_setup. Now, whatever you name your room, you're going to have to spell it the exact same way later. When working with code, capitalization and spelling matter. So it's incredibly important that you name the room the same way that I have it set up here. And then for our other room, we're going to call it RM_game. And this is where the actual game is going to take place. Now, no need to touch anything else here for now. This is perfect as is. But before we get farther into this, I'm going to explain how the sprites are set up for our game. So right here, I've pulled up the GIMP image manipulation program. And we are going to take a look at some of the sprites we'll be using for this game. Now, I'm going to provide all the sprites below for you to check out. Now, when making a game in Gamemaker, you really have to understand sprite sizes and understand how you're going to use them correctly. If you don't set up the room sizes in a very specific way, you're probably going to run into errors later on down the line. Now, I imagine that you don't want to make the exact same game that I made, But being aware of your sprite sizes is going to be very, very important. So let's just go into how I did it, and that way that might help you see how you should do it when it comes time to make your own FNAF Fangame. So let's look at a room here. So the way this is going to work is in Gamemaker, we have multiple images that represent each room. And this is one here that represents this little cubicle looking space. Now as you can see here, this sprite is 3,240 pixels by 2,160 pixels. And every single other image that we're going to be using for the rooms in the game is this exact same size. What I did when I was making these rooms and when I was drawing all of the sprites for the game is that I kept in mind that generally in FNAF you never see the characters moving on screen. Basically what Scott Cawthorn probably did is he put the room as a background like this, and then he would layer the animatronics on top like this. So as you can see in this drawing program, this is just a layer that I can toggle on and off. And I have that for every single enemy in the game. Now something interesting, the dimensions of this image of the enemy are the exact same size as the dimension of the room. That way, when I draw this sprite into the room, I don't ever have to worry about positioning him in the room or getting the X and Y position just right, because he's already positioned just by how I drew him. So, that is how the art is going to work for the game. I've been very, very careful about what the art is supposed to look like and how it ties into the game. And when you make your game, you need to be thinking about this kind of same stuff as well. Now let's go back to setting up our project in Gamemaker. So for the game room, we're going to want to change the size. If I double click here and if I look in my room settings here on this tab, we can see I already set up to the appropriate size. It's 3,240 by 2,160. That's the exact same shape of our sprite. Now if we want to bring the sprite in, and we haven't already, we're going to go here and we can see all of our sprites, and you just click and drag into the sprites folder right here. And as you can see, it imports the image. It's 3,240 pixels by 2,160 pixels. Let's change the name to something that makes more sense. So we're going to name it SBR underscore cubicle underscore 1 underscore background. There we go. A lovely little name. Now remember, this name has to be the same that you use all the time. Now I'm going to delete this sprite because I already imported all the sprites that I needed. And you can see that here. So today we're going to want to import this sprite, which we'll call SBR Antechamber. This sprite, which I called SBR Cubicle 1. This sprite, which we'll call SBR Cubicle 2. This sprite, which we will call SBR Cubicle 3. This sprite, which we will call SBR Cubicle 4. This sprite, which we will call SBR Office Doors underscore closed. And this sprite, SBR Storage Room. So, first things first, let's set up a way so that we can draw in the backgrounds so that we can see what they look like in the game. So I'm going to go here, and I typed most of this code out beforehand, but we are just going to hide it real quick by doing this, and by doing this. So, in your game, right click and click Add Event. So, these are events in Gamemaker, and this is the way they work. Basically, each event runs at different times during your game. So this event here, as soon as this object is created, this event will run. So that means it generally only runs once and as soon as the game boots up. This event is run when this object is destroyed. This event, as far as I can tell, is run when the game is closed or when the object is destroyed. This step event here is run 60 times every second, which is very, very useful. So there's a lot of different events here. What we are going to be interested in primarily is this one that says draw. So the draw event is the exact same thing as the step event. It runs every single frame. However, what's special about the draw event is that you can use certain functions inside it that allow you to do things that the step event can't. So for example, this yellowish orangish kind of word here, draw underscore sprite, that's what we call a function. And if we hover over it, we can actually see what it does. So for example, this function draw sprite takes no less than 4 arguments. This function draws the given sprite and sub-image at a position within the game room. So basically what this is going to do is this is going to draw a sprite for us. And so what we're going to do with this is we're going to say we want to draw the SBR underscore office. Office door is closed. We're going to set the sub image. Now, a lot of sprites in our game can have animations and stuff like that. So if we were to go here, as you can see right here, there's one image. We can go in and edit the image. And we can add an animation here, and that would come up as frame 2. So there'd be 2 frames. However, we don't actually need any more than 1. So we're just going to say, oh, draw the sub image 0. So this would be draw sub image 0. That's correct. And then the position of where we want to draw it in the room. So basically for all sprites have an origin. As you can see, the origin here is at 0, 0. It's in top left, and it's right here. Now, this origin basically decides where on the sprite it will begin to draw. So as you can see, right here is the top left. And if we look in our room, down here in the bottom left, we can see the coordinate points. So if we were to draw the sprite somewhere, it would be here at 0, 0. This isn't quite 0, 0, but it's close enough. As you can see, it would start drawing from the top left part and down and to the right. So it would basically fill all this space up with our sprite. And that's exactly what we want. So we're going to go ahead and do that. Now, we need the game object in this room if it's going to run. If we click run right now, we aren't actually going to see anything. So what we're going to do is, as you can see, I have a room game set up here, and I have a room setup set up here. What we're going to do just for now is on this little house icon, we're going to change the order that these rooms go in. And I'm going to explain why in a little bit, but for now, set it up so that when we run the game, we start in room setup. The little house needs to be on the left. You can change that by just dragging these around, so on and so forth, just like that. Room setup needs to be on top. And then in the room setup, we're going to go over here. Don't bother changing the size of the room. That's fine just as it is. We're going to go to creation code. And we're going to add this line. So this here, this yellow, is our function. Room go to, we can tell because it's orangish. And this red is going to be an asset. So assets are all the things that are here. They can be sprites, they can be objects, they can be rooms. So we're going to set up for room underscore game, rm underscore game. So our game is going to boot up. It's going to start in this room setup, and then it's going to run this code in the room creation code event, and it's going to go straight to room game. So that's set up just how we want it. And then we're going to take our game, which is going to be drawing the room as we want it. We're going to go here to RM game. We're going to take this and we're going to put it in just right there. And if you can't put it in, if you don't see this pop into your room somewhere, double click on this instances layer. So in Gamemaker, each room has something called layers, and like the layers in an image manipulation program like the one we saw before, each layer can have different things on it. So instances basically means objects. So we can like drag in a bunch of these objects here, and so on and so forth. And if you're building a level for like a Mario game, you could basically like line up a bunch of blocks here, make like a whole level and all that kind of stuff. So that's basically what a room is supposed to be. It's like meant to be a place for a bunch of things to be loaded in. So we have the game in on the instances layer in room game. So object game goes there, instances layer. And now if we save the game, and we click this button to run the game. Now if we run the game, we should see, perfect, this. So as we can see the entire room. And even though our room game is black here, this object's code right here is running so that we can see the entire office. Perfect. So first things first, what we're going to want is a camera so that we can look around in this room better. Now, depending on how you set it up, when you loaded this room, it might be all stretched, or it might look really strange, or something like that. Or it might even be that the sprite doesn't come all the way to the edges like this. So this next part should hopefully fix that for you when we make a camera and we work out the resolutions and stuff like that. So let's hit X on this. We no longer need to see it. Our game is just fine. And we're going to create a new object, and we're going to call it obj_camera. Now, I've already set up all the code for this. So let's kind of get into it. We'll go part by part. So first off, one thing that's very important for a camera like the one that we have set up here is for it to be persistent. Now what does persistent mean? It says here that instances of this object will be persistent between rooms. Now what does that mean? Well, basically, this object won't get unloaded when we change rooms. So, what is a room in Gamemaker? A room in Gamemaker is basically this box that contains a bunch of loaded elements, right? Well, if we switch rooms, all the elements in room setup get unloaded, and all the elements in room game get loaded. And then if we decide to go back, all the elements in room game get unloaded, and all the elements in room setup get loaded. Now, we don't ever not want to have a camera for our game. So we're going to set it up in a way so that it's always persistent and it always sticks around with us when we're moving around rooms and stuff like that. So, let's get into how to make this. So, first of all, we want to set up some variables for how big we want our camera to be. Now for the size of this, as you can see, this is the same size as the sprite earlier, 2160. However, the width is a little bit lower than our room. And the reason for that is I don't want the game to be that you can see the entire room at once. I want you to be able to move your mouse and to pan around, similar to how it's set up in the original FNAF, right? So I've set up these two variables that will control that. Another little thing on variables. So variables are these blue ones. These are called local variables. And this view underscore width, we can use that variable in any event that we have set up. This here, this is also a variable, but we've declared it with var. And what that means is that this variable will only exist for this event. So this create event here, it's going to run all of this code here. It's going to set up division up here. It's going to run all of this code. And then as soon as it gets to the bottom here, create will have finished running, and this division variable will simply disappear. And we just do that because we don't really need this division variable that much. We only need it when we're setting up. So let's look at how to do that. So as you can see, right here is where we set up the window. Now the window is basically the box that goes around the game, and we don't want it to be too big or too small. So in order to keep it scaled correctly, I've set up another variable here called window scale that will basically make the window this size, but only that will make it 40% of this size, as you can see here. So view width, that's the width of the window, times 0.4. And we do the same thing. So the view height times 0.4. Just like that. And then let's check here. Resize the app surface. So this more or less has to do with resolution. Resolution is something that's very, very complicated, and I'm not going to get into with a whole lot of detail right now. But basically what we're going to do is we're going to set up the size of all the elements that we're going to draw. So first we're going to resize what's called the application surface, which a surface is, imagine like a canvas. A surface is where things are drawn onto this canvas, and that canvas is displayed on the screen. The application surface is where everything is going to be displayed on default. And so we're going to get that surface, and we're going to resize it to be the same size as our window, just fine like that. And then the display set GUI size. Now the GUI is similar to the application surface. It's another surface that's built into Gamemaker that we can draw stuff on. We're going to get into how the GUI layer is different later. But for now, we're just going to set it to the view width and the view height. Just like that. Easy peasy. Now, what we're going to do here, so this is a really cool thing that you can do in Gamemaker Studio. This is you can set up what's called your own function. So like the same way that these are functions, this is our own function that we've made. So we're going to write center camera, which will hold our function. And we're going to set it equal to function, parentheses, brackets. And we're going to say x is equal to room width divided by 2 minus view width divided by 2. Okay, so what is that saying right there? Well, what that's saying is basically this here centers the camera. So it takes the x of our object and it sets it equal to the middle of the room. Now, the thing is that if we were just to leave it there, it would end up on the right side of the room, because the X of the camera isn't the center of the camera. It's actually like the top left corner of the camera. So we have to move it back by half of the width of our camera so that it's actually centered in the room. And then finally, we're going to set up an alarm. So if you remember when I was talking about events earlier, there's an event called the alarm event. So if we click add event, you can go ahead and add an alarm 0 here. So let's go ahead and do that. And what this does here is basically it centers the window to your display. So your window is going to be right here. Now we can't do that in the create event, because if we do it while we're setting all of this code up, it might end up in like a weird place. So we're just going to set it 1/60th of a second after all of this stuff has been done. So that's the create event. Let's move on to the step event. So first things first, we're going to save this part of the code for later. First things first, so we're going to set up a macro so that we always know what view we're going to be editing. So a macro is very special. Basically, we set up a macro as if it's a variable, kind of. So you set up and you name it. And basically what Gamemaker does is anywhere that it sees this word view, oh, I see it here, oh, I see it here, it's going to replace it with this here. And so all that really does is that means that we don't have to type out this big long thing. We only need to type out this. So the first thing we're going to do is we're going to set the view size. So this will be our camera size. You can set it to a higher number to zoom out. You can set it to a lower number to zoom in. We're going to set it to this width and height we set it before so that everything is scaled properly. These are temporary variables, and we're going to worry about those a little bit later. This code here in this region is the code to move the camera. But for now, we're just going to make sure that the camera is working. Now, this code here, so what this does is this sets the camera position to the X and Y coordinates of this object. What this code does is it keeps the camera from leaving our room. So like if this was our room, we don't want the camera to like whoosh, fling its way all the way out here because we don't have anything out there. We want the camera to stay inside these bounds. So what we did is this clamp variable. With this function, you can maintain an input value between a specified range. So we need to pass in the input variable. So we want this function to edit x. So we're going to put x right here. And then what's the minimum? What's the minimum value that x can be? Well, the left side of our game is 0, right? Well, we're going to say that it can't go lower than 0. Alright, and what's the max value? What's the max value for our x? Well, it would be the room width, right? But remember what I said before. The camera's x and y is the top left corner. So that means if the top left corner was here, it could go all the way to here, and this is when it would stop. It would notice like, oh, hey, I'm at about the room width, so I can't go any farther. But as you can see, the center of our camera would be over here somewhere. Only the top left corner would actually stay inside. So what we need to do is we need to shift it like, okay, you can't go past the room width, but you also can't go past the room width minus the view width. That way, the entire camera doesn't go all the way off screen. So we add that code in here. And then we do a similar thing for y. Even though we're not going to use move y a whole lot, we're going to leave it there. Perfect. So let's add one more event. You can probably see it here. So we're going to add under other, room start. We can see that here. Alright, so without these two, you probably won't see the camera take effect in the room. So this part here is going to be necessary. So what does this code do? Well, this code runs when the room starts. So as soon as this loads, we're going to run all the code in this part right here. So first, in every single room we enter, we're going to enable the use of a camera by setting view enabled is equal to true. We're going to make the camera visible by saying that view visible 0 is equal to true. And finally, remember that function that we set up? That sets our camera's X to the center of the room. Well, we're going to run that code. So you can type center camera and then 2 parentheses. And basically what happens is as soon as Gamemaker sees this, it'll think, oh, I need to run this code. And it'll go here and it'll run this stuff. Boom, done. Alright, perfect. So now if we click save and we run, we should be able to see our camera take effect. Oh, whoops. So I forgot to add it into the room. So what we're going to do is we're going to go to the room setup. We're going to go to instances. We're going to grab our camera and we're going to drag it into the room. Perfect. That's in and that's done. So now we should be able to see. Yep. So as we can see, the camera it's centered in our display. The window set size is something nice and reasonable. And if you want it to be smaller or larger, you can edit this value right here. That's just fine. The camera is centered in our room. And basically the entire camera is working. It's perfect. It's wonderful. Now, let's try to get the camera to move across the screen. So first, how is that going to work? Well, what we want is if the camera is over here off to the left, well, if the mouse is off to the left here, then the whole camera will rotate in that direction. And if the mouse is off to the right here, then the whole camera is going to rotate in that direction. Easy peasy. So let's get into that. Alright, perfect. So I know this part is going to be a little spoiled for you because you probably already saw it. But let's just sit back and let's just think logically. So we want the camera to be moving all the time, right? All the time that the player is moving the camera with their mouse, right? So if we look at these events here, this one only runs when this object is loaded. This one only runs when the alarm 0 is set up. This one only runs when the room is loaded. And this one runs, the step event, runs 60 times every second. So, which one are we going to want to use? Well, obviously the step event, because this is the only event that is going to be running constantly. So, let's look at the code I have set up here. So first, a few notes about how code in Gamemaker works. If you hit // you can type a comment. You can type anything you want in there. If you do /*, it specifies an entire region to be made into comments. And you can end that region with */, as you can see. So now this code is commented out and is not running. This is really useful if you have some piece of code that isn't running, or if you want to write an entire book in your comment section. Whatever you want to do. So we're going to add a comment here, and we're going to say, move the camera. Now, let's just go through it line by line, shall we? I'm going to remove this dead space code for now, just to show you how it works. So first off, what we need to do is we need to figure out where the mouse is. So we need to get the mouse's X position, right? So we're going to see mouse_X. Perfect. So this function will return the mouse's X. And obviously, we want to see what half of the screen that the mouse is on, right? So if it's on the left half, then we move to the left. And if it's on the right half, then we need to move to the right, right? So we can get half of our game with the room width argument, like that. And now what we're going to do is we're going to use this function, the if function. Very useful. You'll use it a lot. So if our mouse X is less than the room width, then we're going to change the X position of our camera. And we're going to say X is equal to X minus 10. Now, I like to use variables for things because it means that it's easier to edit. So I've set up a temporary variable here, underscore speed, which is equal to 10. We're going to copy that and we're going to paste it here. So basically, this does the exact same thing as the code I did before, but it's storing speed in a variable so that we can use it later. And so let's just do the same thing. So we can take this, we can copy it, and we can paste it here. And we'll say if mouse X is more than room width, then X is equal to X plus speed. Perfect. So if it's less than the half the room, move the X to the left. And if it's more than half the room, move the X to the right. So let's go ahead and see what this does. Alright, as you can see, my X is to the left and immediately started moving to the left. Now if we go to the right here, perfect. So now it's moving across the screen. That's perfect. That's wonderful. That feels really smooth. However, there's a small problem. As you can see, my camera isn't moving. As you might have guessed, we are very clearly on the right side of the screen. So what's happening exactly? Well, the thing is, right here, like this, about this space here, between these tiles, this entire column here, that is the middle of the room, which is where we set the room width to, right? Well, that position doesn't actually move with us. So if the camera is off to the left, the middle of the room is still going to be about here, which means that it's not the center of our camera. So that's really weird. How exactly are we going to fix that? Well, I'll tell you how. But first, allow me to show you a quick example of something. Alright, so right here, I've set up a little example. What I've basically done is I've made it so that all of the coordinates draw onto the screen. So as we can see, as we move the camera, these blue X coordinates move up until they get to the right side of the screen. And that's basically how that works. But right above, as you probably have already seen, we see more coordinates that are red, and they don't move when the screen is moving. So why is that? How does this actually work? Well, it's actually really quite simple. You see, these blue text is being drawn in the draw event. This is the default event for everything that draws in your game. So everything is going to be on this layer. Like the step is going to use these coordinates. The draw is going to use these coordinates. And these coordinates are room based. So the room X equals 0 is over here on the left. As we journey throughout the room, we can see that the X coordinates continue to increase. However, there's another system of drawing, which is draw GUI. And these are all the red coordinates. As we can see here, these coordinates are relative to the camera. So 0 is the top left corner of the camera. As we go across the camera screen, the numbers scroll up. And it doesn't matter if we move the camera because these numbers are relative to the camera. So they'll always move when the camera moves. So what we want to do is we want to use GUI coordinates instead of normal coordinates in order to move our mouse. So we're going to delete these two events. I just had them open to show you what they looked like. And we're going to go ahead and do that. So first off, this mouse X, it shows the position of the mouse relative to the room. However, there's a useful function in Gamemaker language to get the mouse position relative to the draw GUI. And it's this one here. So this is the device position. This is the mouse position relative to the GUI layer, relative to the camera, if that makes sense. So we're going to replace those. And then we also need to replace this. So basically, if we can figure out how big the camera width is, we can essentially just make sure that this number is less than or greater than that middle spot on the camera. So we could use view width. That would probably work as well. But I'm actually going to use this function here just to be absolutely safe. So this will get the width of the GUI surface, basically the width of the camera more or less. And it's going to get half of that, so as soon as it passes half of the camera's width relative to the camera, then it'll move. And now if we run the game, we should be able to see that this works much better. Perfect. So as you can see, it's always in the middle of the camera that we change from panning left to panning right, and so on and so forth. And that's really, really good. So that's excellent. So one thing that we're going to want to do is we're going to want to make sure that there's some kind of dead space in the middle where the camera is not going to move. So we're going to make another variable like this, var underscore dead space is equal to 450. That's what I have set up here. And we're basically going to say, okay, minus 450. And over here, plus 450. So you see how that's different? So basically what that means is that there's going to be a 900 pixel gap in between here and here where the camera will not move. So like it only moves if it's there, it only moves if it's there, but if it's in neither of those, it's not going to move. So if we run this, as you can see, now there's a little bit of a dead space here. And it's only when we get more towards the edges that the camera actually starts moving. That's wonderful. That's perfect. Okay. So if you want to change how much dead space there is, you can simply change this number here. And that's all that we have to do for that. Wonderful. So now that's 100% working. So now what we need to do next in our game is to change what room we are going to be looking into. So right now we have the office, but we want to be able to change this background to whatever we want. Well, fortunately for us, we already have the background drawing into the room. It's drawing here. However, it's time to replace all of this with a better way to draw it. So what we're going to do is we're going to set up a variable. So let's go to the create event and just see how this works. So the create event is going to run exactly one time as soon as this object is set up. It's the perfect place to set up some default values. So we're going to take a look at all of this stuff here. So first of all, I'd like for you to just ignore this top left, bottom right, all of that nonsense. I'm going to explain what that's going to be a bit later. That's going to be more for our buttons and stuff like that. But we're just going to ignore it right now. So all the room you're actually going to need is this code here. So basically, each room in our game is going to hold a certain amount of data, right? Well, the best way to hold a little bit of data is with a data structure. Now, there are a couple of different types of data structures in Gamemaker. And one of the most useful ones is the struct. A struct is set up like this. So you have the name of the struct equals and then brackets. And then inside these brackets, you can set up something. So like if we want, let's say max underscore health. You semicolon, and then you do a number, 9. That's wonderful. And you can put as many of these variables as you want. So if we want to do damage, just like another variable, that could be 20. Variables like this can actually hold a lot of different things. So if we wanted to hold a sprite, we can do something like that. So as you can see, this struct is now holding all of this data. And then if we want to do something with that, all we have to do is, wherever we want to use it, we just type out struct dot to access the variable inside, and we can see the variables that there are inside this struct. So if we want to use the sprite variable, we can use the sprite. So, with that example out of the way, we're going to create a specific struct for every single one of our rooms. For now, just copy the non-commented code. So just office room is equal to, and then we're going to set up the sprite, and it's going to be the sprite for the office room. Cubicle 1 room, we're going to set up the sprite, and it's going to be the cubicle room. Cubicle 2 room, sprite, SBR cubicle 2. Cubicle 3, sprite, SBR cubicle 3. Cubicle 4, sprite, SBR cubicle 4. Antechamber room, sprite, SBR antechamber. Storage room, sprite, SBR storage room. And then we're going to set up another variable, and we're going to say, okay, this variable right here, current room, the room that we are currently in, is going to be equal to office room. Perfect. And what we're going to do is, in draw, we're going to say that the sprite we're going to draw is going to be the current room.sprite. So basically, once Gamemaker sees this, it's like, okay, I have to get the sprite out of current room. So it goes over to current room, and it's like, okay, current room is equal to office room. So I got to get the sprite out of office room. So it goes to office room. It's like, okay, the office room, the sprite is SBR office doors closed. So I'm going to draw this sprite here. So it's the same thing as what we had before, which looked something like this. But now, if we change current room, we can draw something else. So if we run this, we should be able to see, look, the office room is drawn the same way. But if we go ahead and we change this to, let's say, antechamber room, hit save, we run the game. As you can see, it's now a different room. That's wonderful. That's excellent. So, all of these rooms are now set up. And that's great. That's perfect. However, right now, we don't really have a way to change rooms. Like, we have it set up here, but we need a way to change current room. So let's work on that. So, first off, we're going to go to the step event, and we're going to do some things. Actually, we're going to go to the draw GUI event first. Now, this is a draw GUI event, and remember that this is relative to the camera. So what we're going to do is we're going to draw what I call the GUI. Now, GUI stands for Game User Interface. And it's basically like a collection of buttons. So this is the camera GUI. This is what the player will see and what they can click on in order to change camera rooms and all of that good stuff. So for the origin, we're going to want to put it at top center. And what we're going to do is we're going to draw this onto the screen. So in room game, in the object game, we're going to go here to draw GUI. And let me just check what part that we need to draw. So we're going to draw this. So we're going to exit out of that. hide this, hide that, hide this, hide that. Perfect. And we need to figure out where we're going to draw it in the room. So, for now, you can just use this and this. Okay, so let's break it down by what this is going to do. So, this is going to draw the sprite, SBR camera GUI, at an image index of 0, because it's not an animation. And it's going to draw it at XX and YY. So where is that? So, as you can see, we got the display get GUI width. So that means that it's going to be in the center of the camera. And display get GUI height minus sprite get height minus 50. So what this means is if we look at this, so this is the top of the sprite, right? So if we drew it at GUI height, it would draw right here. And then the rest of the sprite would be down here somewhere. We wouldn't be able to see it. So first what we do is we lift it up by the sprite height of the sprite. So that means that it goes up by 565. Then we're going to lift it up just a little bit more by 50, which is just so that it isn't touching the edge of the screen. It looks a little bit better. So we're going to draw that sprite there. Alright, that should be all the code that we need. If we look, we should be able to see. Perfect. So now we have this GUI interface right here at the bottom of our screen. Easy peasy. So, now what we need to do is we want it so that when the player clicks inside one of these, it transfers to that room, right? However, that's a little bit complicated because this spot right here is in a different spot than this spot, and this spot is a different spot than this spot. How are we going to figure out the positions for all of these? Well, what we're going to do is we're going to figure out what's the top left pixel of this box. And we're going to figure out what's the bottom right pixel of this box. And then what we're going to do is we're going to store all of that in a data structure. And then we're going to check if the player's mouse is inside of any of the boxes that we've set up. So that sounds pretty complicated, but let's just go and see it really easily. I'm so bad at talking when I do this. I am so sorry. That sounded so strange. Okay. So, we're going to ignore all of this code for now. So, debugging. So, what does the code down here do? Well, you can full screen the code here. As we can see, so we're going to check if mouse button pressed, mouse button left. So we're basically going to be checking, okay, has the player pressed the left button on their mouse? So like the button that you generally use to click around and stuff. If so, show debug message string, so device mouse X to GUI, string device mouse Y to GUI, etc. So what does this all do? Well, first, we know what this does. This basically prints out this finds the position of the X position of our mouse on the GUI layer. And this finds the Y position of our mouse on the GUI layer. Now, this function here takes in a string. So we need to change this over to a string. So we're going to say string. We're going to change this number from a number into a string. A string is basically text. So like this here is a string. Hello world. And generally you can print that out onto the screen, or you can draw something with it, or all kinds of stuff like that. So we're going to convert this to a string, this to a string, and we're going to format it. So this is going to be basically like a number, so like it'll be like, oh, 165 or something. 165. And then we're going to add on this semicolon to it. So the quotation mark plus quotation mark, etc. This will appear like this. And then we're going to go ahead and add on the Y section. So if this Y was something like, oh, I don't know, 225. It's going to add on. So that means that in the end, this would be what we would end up with. Something that looks like that. And then the show debug message, what this does is it outputs something into this output tab down here. So, what does this code do? Well, all it really does is when the player clicks, it outputs the position of the click down here. So if we run our game with this code in the step event, if we click up here, as you can see, perfect, 147 by 180. So all we need to do now is we're going to click the top left of the storage button, as we can see 977 1550. We're going to go back to our create of our game object. So we clicked in the top left of this storage room, and then we're going to go here to the storage room, and we're going to add in those coordinates. So you may be like, okay, Gatsby, what is this here? Good question. So we're going to set up a new variable in our struct, which is top left, which contains the top left coordinate of our room object, of our room, of the button for the room, right? This here, this thing defined in brackets, is something called an array. An array is another very, very useful data structure in Gamemaker. There's a couple of ways to set it up, but basically we're setting it up like this. Now, an array can hold all kinds of things. It can hold strings. Hello. That's not how you spell that. I'm so sorry. It can hold numbers. It can hold sprites, etc. Whatever. It can hold all kinds of things, right? And basically, to call from an array, all I have to do is do 0. So this here would return the index at part 0 of the array. So here's 0, here's 1, here's 2. So if this was 1, this would be equal to 1, 2, 3. If this was 2, this would be equal to sprite. And if this was 0, it would be equal to hello. So it's a very, very handy way of storing variables. Now we're going to create a small array in top left that will be the x and the y position of our box. So we figure out the top left coordinate of our square. All we really have to do is in top left, we put this coordinate, and done. Perfect. Now we're going to do the same for the bottom right. So we're going to do bottom right, another array, and then right here, in the bottom right position, click, 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 come on. We can scroll down, as you can see, 1505, 1635. We're just going to take that, and we're going to put it right in our array. Perfect. So we're going to go ahead and do that for every single one. Now, if you just copy my code exactly, it probably will work. But if you have different sprites or different button setups and stuff like that, you might want to do something a little bit different. So we're going to set up all these arrays just like that. Perfect. So as you can see, our structs are proving very useful because not only do they tell us what each room is going to look like, but they also tell us where we're going to need to click in order to go to that room. So now let's add in some code that will allow us to actually move rooms. We can delete this alarm event, by the way. We don't actually need it. So first of all, let's set up a new array that holds all of our rooms. So all rooms is equal to office room, cubicle 1 room, cubicle 2 room, cubicle 3 room, cubicle 4 room, antechamber room, storage room. So all of the rooms are now in this one handy dandy array. And you're probably thinking, Gatsby, why did we do that? Well, it's very, very simple. You see, right now we could check if the mouse is inside the office room, right? And then we could check if it's inside the storage room and all that stuff, right? Well, that's actually a lot, and we have to go down and do that for every single one. So that sounds like just a massive pain. So what we're going to do is we're going to use something that's very, very useful in Gamemaker Studio. This bad boy right here, not this, that'll be for later. This right here is basically, it's going to loop through all of the rooms, and it will check if the mouse is inside the box for every single room. So how does that work? You see, what this does is it sets up a temporary variable called I. So I starts at 0. 0 is right here in our list. And what it's going to do is, as long as the I value is less than the size of this whole array, so 0, 1, 2, 3, 4, 5, 6, as long as this number is less than 7, I will continue to increase. And then, once all this part is done, it's going to run this code here, all of the code that's in these brackets. And it'll do that for every single room in our array. Very helpful. So basically what we're going to do is first we got to define the box for our current room. So basically the button boundaries, right? So we're going to get the current room that we're editing. So in our all underscore rooms, we're going to figure out which one we're editing. So this could be any number between 1 and 6. But because we're using this I, we can get that. So it's first it's going to edit this one, it's going to check this one, then it's going to check this one, then it's going to check this one. And it'll do all of that instantly for us without us having to really work for it. So it's going to get, okay, so if this starts at 0, it's going to get the top left part. So it's going to go, okay, we're at 0 right now. We're just starting off. We're going to go to the office room, and we're going to get the top left. So office room top left is this array here. Perfect. And it does the same for the bottom right, and so on and so forth. So it's going to go, okay, we're currently at 0. We're going to look at office room. We're going to get the office room bottom right. Perfect. Done. Now, what we need to do is we need a function that will tell us if a point is inside a rectangle. And for this function, we're going to use this incredibly useful and creatively named pointInRectangle function. So what we need to do, how does this work? Well, if we hover over it, we can see. When using this function, you define a rectangular area, and Gamemaker will work out whether the given point falls within its bounds or not. So it takes several arguments, as you can see, px and py, the x coordinates of the point to check, and the y coordinate of the point to check. And there's x1 and y1, the x coordinate of the left side of the rectangle to check, and the y coordinate of the top side of the rectangle to check, and then x2 and y2, the x coordinate of the right side of the rectangle to check, the y coordinate of the bottom side of the rectangle to check. So, as you can see, we've set it up perfectly to use this. So we're going to get the mouse X and mouse Y. Remember that this is all relative to the camera because we're going to be drawing the camera GUI in the draw GUI event. So we're going to want to check the mouse position relative to the camera, the mouse X and Y position relative to the camera, and then what we're going to want to look for is the top left coordinate. So we're going to start at the top left. Okay, so it's going to go top left is equal to the 0 position in the array top left. So what's the array top left? Well, the array top left is equal to all rooms 0 dot top left. If we go here, okay, all rooms 0, all rooms index 0 is office room. So we're going to go to office room, and then we're going to go to the top left, and the 0 index in top left array is 1145, which is the X coordinate. So it's going to check, okay, so this is the X coordinate. We're going to go to the same for the Y. So the Y coordinate of whatever one we're running. And then we're going to find the bottom right coordinate. So that will be here. Then the bottom right Y coordinate, which will be here. And so on and so forth. So, if the mouse is inside these bounds, then we're going to use the exact same function we used earlier. We're going to check if the mouse button is being pressed, if the player is clicking, and you're inside the button bounds, then we're going to set current room equal to whatever room we're running. So remember, this is going to start at here, at 0, office room. It'll check if the mouse is inside the office room button bounds. Then it'll check if we're clicking, and if we are, we're going to set the current room equal to index 0, which is office room, which is this. So we're going to set the current room equal to that room. And then once this code runs for the office room, it's going to go ahead and move on to index 1. So it'll check, okay, if the current room is equal to cubicle 1 room, and the mouse is inside these bounds, set up here, and the player presses, then set the current room to cubicle 1 room. And once that's done here, it'll do the same for this one, and this one, and this one, and this one, and all of these. So, if we run the game, we should see that that's working. So if we click here on storage, boom, storage. Click one on cubicle, boom, cubicle. Doop, boop, boop, boop. It all works perfectly. Excellent. So, that is now working excellently. So, one thing that we have to keep in mind is that the player is probably not going to remember what room they're in. So we need to add in some kind of feedback so that they know where they are and stuff like that. We're also going to add in a few more visual features to keep the system here very similar to what we have in the original FNAF. So we're going to go ahead and add that in now. So, as you remember from the very, very beginning, we're going to add a flashing rectangle on top of the button if we're hovering over it. And we're going to add another flashing rectangle over the button if we're inside, if we're looking at that room. So, we're going to draw all of this in Draw GUI. And we're going to draw it over the sprite that we're using right now. Now, if only we had figured out what the box bounds for every single button for every single room is. That would really make this easier, huh? Okay, so let's go into how this is going to work. And we're obviously going to be using a similar system to what we did here. So first off, let's comment this part out for now. I'm going to explain what that is in a second. So this is where we're drawing the GUI sprite, right? Well, we're going to want to draw our rectangles on top of this. So basically, think about it like a list of instructions, right? So first, Gamemaker is going to do all of this stuff. It's going to set up all these variables. That's why these variables need to go at the top of the event. Then it's going to draw this sprite. Then it's going to draw something on top of the sprite. If this was after this, then it would draw the rectangles under the sprite, and that would be a massive problem. So we're going to have this here, just like that. And we're going to do a similar thing to what we did here in the step. So we're going to check if the mouse is inside every box. So it's going to be a similar system. We're going to loop through. We're going to get the same coordinates that we got here. It's working the exact same way. And let's break this into pieces here. I'm just going to hide this part with a region. Bada bing, bada boom. Okay, perfect. Let's actually comment this out so that we can focus on one thing at a time. Alright, so we're going to do two things here. Here's where we're going to draw a rectangle on top of the one we're already in. And here's where we're going to draw a rectangle over the one we are hovering. So let's do this one first, because it's very, very simple. Basically, all we really need to do is we need to check, okay, so is the current room that we're checking, is that actually the current room? Like, is the player looking into this room? If so, we're going to draw a rectangle on top of it so the player knows that we're in that room. So these are draw set functions. They're very, very common. There's a lot of them out there. And what this does is it sets the base color for stuff. So we're going to set the base color to white. And this is the draw set alpha. So this is going to set the opacity of whatever we want to draw, right? So both of those are going to affect this here. So we're going to use the draw rectangle function, very helpfully provided to us by Gamemaker. That is going to draw a rectangle. So what are rectangle X and Y bounds going to be? Can you guess? Well, it's going to be the same as the button before, right? So I'm going to say top left X, top left Y, bottom right X, bottom right Y, and then this outline. So if we hover over this, we can see with this function you can draw either an outline of a rectangle or a filled rectangle. So we're going to want to draw a filled rectangle because an outline of a rectangle isn't as impressive. So we're going to set this equal to false. Like, we don't want it to be an outline. We want it to be the full thing, a filled in rectangle. So, and then what we have to do is we have to reset what we did. So if we just left this like that, then these settings would spill over into the drawing of everything else. So everything else would be this alpha. Everything else would be like slightly opaque, it would be white, whatever. We don't want that to happen. So we're going to reset it. And these are what the default variables for them are. So the default variables for the set color is C white. I know that that doesn't look like we're changing anything, but I'm just going to leave it like that, just in case you want to go here and you want to change this to like blue or something. And then the alpha, so this is a number between 0 and 1. So it's like a percentage number. So if we put 0.5 here, everything is going to draw at half of its opacity. So when we're resetting this, we want everything to draw its full opacity, so we set it equal to 1. But for our rectangle, we're going to want to draw it at an opacity that's going to change constantly. So how are we going to do that? Well, I don't know if you've ever taken trigonometry. I'm not even actually sure if that's the right term for this, but we're going to use the sine variable because a sine function is basically a wave. It goes up and it goes down, and that's exactly the kind of behavior that we want for the opacity of our rectangle. So we're going to check sine, and then inside the sine object, we're going to put this number, which is current time. So current time is something that always increases the longer your game is running. So when we graph a sine function, generally use x because x is going to change all the way across and whatever. But in this case, we're going to use current time because we have another variable that's always increasing. So we're going to use current time. And notice here, this read-only variable will return the number of milliseconds that have passed since the game was started, which is always going to be going up, right? Now, if we use milliseconds, this is going to change very, very quickly. So we're going to use divided by 100 in order to slow it down just a bit. And then what we're going to do is we're going to take this, and generally this is a number between 1 and -1, right? Well, as I explained before, we don't actually want to draw at a negative number. Like, there's no negative opacity. Like, something can't be like -1 clear, right? So we're going to set this equal to 0.5. So we're going to multiply it by 0.5. So this is always going to be either, all of this together is either going to be -0.5 or 0.5. And then what we're going to do is we're going to add 0.5 to it. So that means that sometimes this is going to be 0, in that we won't be able to see this. And sometimes this will be 1, and we'll be able to see the entire rectangle. And sometimes this is going to be 0.5, which means that this is going to be at about half opacity. So if we go ahead and run that now, we should be able to see this code running correctly. So as you can see, it's currently a blue flashing rectangle above the antechamber, which is where we are right now. If we click on storage, it shows us storage. Blue rectangle, perfect. If we click on U, we can now see the office, perfect. And for all the cubicles. So now we know exactly where in the building our camera is currently showing us. Very useful. So now what we want to do is we want to do something similar, but for the one we're hovering over. So this is going to be very, very similar to the code that we've set up. We're going to do basically the same thing that we did here in step. We're going to check if the point is in rectangle. So like, is the mouse inside the button bounds? If so, we're going to set it up again. So we're going to make this rectangle yellow this time. We're going to set the alpha to the same thing as the other one. So it's going to flash just the same way. Exactly the same. And then we're going to draw the rectangle here. So it's the exact same way that we drew the rectangle up here. Nothing has changed. And then what we're going to do is we're going to reset it again. So draw set alpha, 1. Draw set color, white. Perfect. Now we're going to run that, and we're going to see. Perfect. So now if we hover over this, we can see it flashing yellow. Flashing yellow, flashing yellow. All kinds of good stuff, right? And now we can click around. Just like that. Oh, it looks lovely. It looks absolutely excellent. So, that is very, very well and good. So something interesting about most FNAF games, as I remember it, and I say that, and I will be honest with you, I have not played any Five Nights at Freddy's game at all. None of them. but I have watched them, and I know how they play. Generally, when we're in here, which is supposed to be our office, you cannot see the menu here. Like, this menu is hid from you. So, let's go ahead and do that too. So basically, we want it so that we don't show the GUI in the office. So we're going to add this if statement, and we're going to put all of our previous code inside of it. So it's going to say current room is not equal to office room. So basically, if our current room, if the room we're currently in, this symbol here, this exclamation mark, in code means not. So it's going to be if not equal to the office room. So that's this one here. You know, the office room where we like hang out and stuff. If it's not equal to that, then you can draw all of this stuff. Otherwise, don't draw it. So if we run the game now, if we click U, voila, it disappears. Now you're probably thinking, okay, how do we get back to that? Like now we can't access our camera anymore, right? Well, what we're going to do now is we're going to make it so that when the player hits the space button on their keyboard, their camera opens, similar to the way it does in like the actual FNAF. Their camera opens and it shows the last one they were on. So like if the player was looking in this and then they clicked on the office, they're going to be able to hit space and then it'll show them right back in the storage room again. So let's do that. Let's go over to step. And right before we do that, actually, let's set up a few more variables. So we're going to want, let's change the current room that we start off in to make it be the office room. So that way, as soon as we boot up the game, we're automatically in the office room. And then what we're going to do is we're going to set up a last room variable. So this last room variable is just going to hold the last room that the player was in. So the last room is going to be equal to the storage room, just when we start up the game. So if we go here to step, as soon as we click on a new room, we're going to update the last room. So we're basically going to check here, okay, if the current room is not equal to the office room, so like if we didn't just go to the office, then the last room is equal to the current room. That means that last room is going to be whatever room we're currently in besides the office. And then let's add some open laptop functionality. So if keyboard check pressed, so if we have just pressed the spacebar, then our current room is equal to the last room. So if we just press this, we're going to go back to the last room we were looking at that wasn't the office. So if we save and run, so we see no GUI here, but never fear, if we hit space, we can now see that we're in storage. We can check this cubicle, we can check that cubicle, we can go back, we can look around our office, see that there's nothing fighting us, and then it takes us right back to the last room we're looking at. Wonderful. That's perfect. So that is going to be all for today. As we can see, we now have the basic camera functionality of Five Nights at Freddy's working. You can now look around and see everything that we want to see. This is wonderful. So in the next video I make, in the part 2 video, I'm going to be going over the AI for the enemies, basically how to put animatronics in here, how to make them move through the rooms, and all that good stuff. But if you enjoyed this tutorial and you found it helpful, go ahead and leave a like, leave a comment about the kind of game that you want to create, and about any questions that you have, and I'll try to respond to them in a timely manner. And if you really want to see the next tutorial and want to be notified as soon as it releases, go ahead and hit subscribe and hit that bell so that you get an email notification. Alright, that is going to do it for today. Thank you so much for watching, and I hope that this video helped you out a bit. Have a wonderful evening, old sport.